Good morning, folks. My name is Mike, and welcome to Space News, Day 7. Let's get into reading a space article by. Okay, woof. Let's restart. This is one of the reasons I live stream and I don't edit my videos because I would spend a bunch of time cutting out what I just said. Hi, my name's Mike. Welcome to Space News. I read the news so you don't have to. Let's see what we have on Ars Technica. A couple of new articles, Eric Berger, John Timmer. It's a new author. Typically we have Eric and Stefan as our authors. What do we want to read? Something about a Japanese spacecraft face planting on the moon. This was their SLIM mission. We talked about this back in episode 4 or 3. The Ingenuity is on its last legs. There's something called a LIGO, which goes to space. And the ESA will proceed with, it's a gravitational wave detector. That sounds pretty cool. And lastly, Iran reaches orbit. Chinese firm achieves impressive landing test. Bunch of good articles. We had learned about the SLIM mission previously, so it could be interesting to follow up. But let's go to the Ingenuity. Maybe we can rip through this fast if it's not super technical. Okay, so the U.S. Space Agency has not made any public announcements. Sources are saying one of the blades is broken. That's really unfortunate. In the photo on the top of the screen, we can see the Ingenuity helicopter with 2 blades. This diamond pattern is quite interesting. And a solar panel on the top with its 4 legs that look like golf clubs. Woods. All right. The Ingenuity helicopter was an experimental mission. NASA engineers wanted to see if they could devise and build a vehicle that could make another powered flight on another world. Mars has a very thin atmosphere, less than 1% of Earth's, and the solution they landed on was a very light 4-pound helicopter with 4 blades. 4 blades. 1, 2. Where did we go? 4 blades. It hoped that engine. Well, I guess it would make sense for packing reasons. Maybe the blades are hidden. Yeah, there you go. There's another one that's underneath the. So the blades, I guess, in this resting position. Perhaps this is after they've deposited this from the whatever vehicle got this to Mars. The blades are underneath each other, two on one side, 2 on the other. It makes sense as a packing configuration. So the helicopter has flown a staggering 72 flights after its deployment from the Perseverance rover, the vehicle that deployed it onto Mars. It has spent more than 2 hours flying over Martian air and flying just over 17 kilometers. Wow. It was developed by NASA and JPL, or the Jet Propulsion Lab. Getting on in Martian years. 1 week ago, during a simple hover test flight, NASA lost contact with Ingenuity. The mission operators restored comms by asking the Perseverance rover to perform a long-duration listening session for Ingenuity's signal. Okay, so Ingenuity can speak with its deployment vehicle, Perseverance. Very cool. Let's have a quick look at Perseverance, which is the Mars rover. We've talked about this one as well on the show. Let's see. Okay, so did that move? Oh, very cool. Wikipedia has added GIF might be the wrong term, but it looks like a GIF. Duck typing here. It walks like a duck. It quacks like a duck. It's probably a duck. Probably a GIF. Yeah, so this is the Ingenuity rover. These very cool. It's a very cool 6-legged vehicle with a bunch of sensors on a head that allow it to image, get itself around. Back to the article. Before that flight, on the helicopter's 71st flight, the helicopter was supposed to traverse a long distance, so 358 meters, reaching an altitude of 12 meters and spend nearly 125 seconds airborne. NASA has sought to reposition the helicopter for future flights to survey new areas of the Martian surface. However, during that flight, Ingenuity made an unplanned early landing. Very cool. Kind of a side project for NASA, and I'm really happy to hear that it worked out well for this long. Got over 70 flights. I'm sure they picked up a bunch of data. They know what they can do for the next series of flights for the next helicopter that they want to put on Mars and other, other celestial bodies, the moon. All right, we have 3 other articles that we can go through. I'm going to pass on the Iran reaching orbit for now. Sounds more political than technical. So between the SLIM mission and the Japanese SLIM mission and LIGO, let's learn a bit about gravitational waves. So it will be sensitive to unexplored phenomena. On Thursday, the ESA gave the go-ahead to the Laser Interferometer Space Antenna, or LISA, project. This would mean the construction of the mission's 3 spacecraft could begin as early as a year from now. So in the image above, there are 3 yellow vehicles with massive solar antenna arrays and laser and solar antenna. Just solar panels, and 3 lasers, very large lasers going in between the vehicles. Well, the interferometer would follow the same basic principles as ground-based LIGO experiment that first detected gravitational waves. The hardware would be placed 2.5 kilometers apart, making it sensitive to an entirely new range of astronomical phenomena. I assume they would put these vehicles outside of the influence or significant influence of any planet. I'm curious what the game plan is, what kind of impact gravity will have on, or gravity will, or I guess if they're all relatively close to each other, I mean, 2.5 million kilometers apart. I was, for some reason, thinking 2.5 kilometers apart. Okay, if these things are 2.5 million kilometers apart, are they not worried that the gravitational influence of 1 or 2 celestial bodies close to one object will influence the trajectory and therefore the geometry of the alignment of the 3 vehicles? Maybe they don't care. Maybe they can, my goodness, adjust for where the vehicles are, and make those. I mean, they must be able to, and make those changes to certain coefficients in the LISA project. Proven tech. Existing gravitational wave detectors rely on bouncing lasers back and forth between distant mirrors before recombining them to produce an interference pattern. Okay, so the vehicles position with respect of each other. I mean, you could, even if it's here or here, you can still bounce a laser off of it. And what matters is measuring the interference pattern on the receiving path. Anyway, anything that alters the position of the mirrors, from the rumble of a large truck to the passing of gravitational waves, will change the interference pattern. Let's have a look at the LISA or LIGO interference. Do we have any images of what that interference might look like? So here's one mirror, here's another mirror. We have the central vehicle sending lasers off to these mirrors, bouncing. That laser will bounce off of them, and then it will measure. There's beam splitters and beam splitters. I'm sure there's a series of beam splitters, lenses, amplifiers that will push that signal to the detector on this little blue square here. And if the arms are disturbed by a gravitational wave, the light waves will have traveled different distances. Light then escapes through the splitter and hits the detector. And the interference patterns that we would expect look something like this. So there are hotspots or nodes. Similar here, more hotspots. Oh, look at that. So here is a depiction or an artist's rendition of the what I assume will be the LISA experiment. You have black holes sending out or creating perturbations that manifest as gravitational waves. And the LISA experiment is somewhere away from them, detecting the ever slightest change in the I guess the interference pattern of light that's sent out from one vehicle to other vehicles 2.5 million kilometers away, and that tells us that yes, in fact, there are gravitational waves do exist, and we can continue to improve technology to better spot them. To capture more of the process, we need to detect low frequency gravitational waves. And that means a much larger distance between the interferometer's mirrors and an escape from the seismic noise of Earth. So the LISA design consists of an outer shell of a spacecraft that absorbs the jostling of the dust and cosmic rays that tear through our solar system and powers a laser strong enough to reach 2.5 million kilometers in a vacuum. It will also house a telescope to focus incoming laser light, which will spread from its normal tight beam over these distances. Floating freely within that is a mass isolated from the rest of the universe, should provide a stable platform to pick up any changes in the laser. 3 spacecraft trail the Earth in its orbit around the Sun, each sending lasers to 2 others in triangular configuration. So exactly what we see here. The Earth is orbiting, maybe not we can't see the Sun in this picture, but the Earth, let's say, is orbiting in this direction. We have the LISA experiment just trailing that, orbiting in the same path. This may sound like science fiction, but ESA has already sent a Pathfinder mission to space to test the tech, and it performed 20 times better than planned. Very cool. Going supermassive, once it gets to space, it should immediately pick up the impending collisions that have resulted in LIGO detections, but it will spot them as much as a full year in advance and allow us to track where the event horizons touch. So we're talking about the event horizon, the collision of the event horizons of 2 black holes, again as depicted in this image. Thank you very much, Sayo Studio. That really helped. They even used an image or depiction of water droplets colliding. Maybe this one will will illuminate us. Beam splitter, mirror, 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 mirror. Okay, same. Perhaps the most exciting prospect is that LISA could pick up the early gravitational fluctuations formed in the immediate aftermath of the Big Bang. This has the potential to provide a new view into the earliest history of the universe, one that's completely independent of the cosmic microwave background. Very cool. Thank you very much, John Timmer, for the article. What time are we looking at? Right now, we've been streaming for 13 minutes and 35 seconds. We can rip through the SLIM mission. I'm curious. So despite engine failure, SLIM mission managed to achieve the most precise moon landing ever. So this mission, instead of a vehicle landing, within kilometers of its intended target, apparently was able to land within 300 meters or so. So about the size of a small car, the SLIM landed on Friday, or Small Lander for Investigating Moon, making Japan the 5th country to achieve a soft landing on the lunar surface. Shortly after landing, the battery was not recharging, and so the mission was over. With the benefits of 6 days of data crunching and analysis, they briefed reporters. Indeed, the spacecraft toppled over after touching down, with its nose planted into the lunar regolith. I assume that's the surface of the moon, and its rear propulsion section pointed towards space. It turns out that Slim overcame a lot to get to that point. One of their engines failed. Wow. Still, even with the engine gone, the $120 million robotic mission made the most pinpoint landing on the moon in history. So how it planned on doing this was, I believe, akin to, again, you'd have to go and rewatch the episode, day 3 or day 4 Space News when we covered this. But I believe that they used a SpaceX style landing to kind of engine fire landing to get themselves to a very precise point. I mean, they're not landing on a floating space pad in the ocean. But they were targeting a small area on the moon. Once they would come in with through a vertical descent with their engines firing, they'd come off, and then the spacecraft, once it got closer, would it was kind of cool how they wanted to land on the moon. It would angle itself, and then it would have a first pair of feet touch down, and then the second pair of feet touch down slowly, and you'd come to rest horizontal with its engine parallel to the moon's surface. That's not how it happened, but the next one I'm sure will be better. One of 2 tiny robots released by Slim just before landing relayed a remarkable image of the lander standing upside down a short distance away. This might be the first close-up view of a crash landing, however gentle, on another world. So there's the nose of the Slim, there's the engine, one of them. Interesting band. I'm curious, when they transmitted this information back to Earth, it seems like they lost the information from a couple of spots. I guess they could have taken they could have put in the effort to try and correct those, but I actually appreciate the fact that they didn't. You know, nothing is perfect, and more than anything, I think people want to see real. You know, they want to believe. There are already enough people that don't believe that we landed on the moon, or that, you know, space travel is possible. It's probably a good thing to leave in blunders and just show this is what we got. This is exactly what our camera takes. And, you know, there are some technical difficulties like missing packets from the during the transmission, but that's fine. Beautiful resolution of certain features. Lots of moon dust, moon rock, or what did they call it? Lunar regolith. You can even have a look at that. So lunar regolith covers almost the entire surface. It's bedrock protruding only very steep-sided crater, bedrock protruding only on very steep-sided crater walls and the occasional lava channel. Okay, anything else here? Talking about what went wrong. When the engine suddenly lost thrust. Slim had 5 crushable landing legs. So they use a similar methodology to how cars are built. So the front of cars are supposed to be crushable in the event of an accident. So that metal absorbs some of the shock and slows you down, so that it's not your body experiencing that. One of the engine's nozzles fell off the spacecraft. Wow. And that explains why in this photo we can only see a single engine. I mean, it's not that kind of... Maybe you could say that's an engine in the back there. Don't know. Here's another image. So they stitched together 257 low-resolution monochrome images taken by their multi-band camera to create a mosaic of the landing site. That's very beautiful. It actually reminds me of my not the rock, but the overall landscapes reminds me of a hill in my hometown. So Slim was designed to operate for nearly 2 weeks until sunset at the end of the lunar day. Unfortunately, it will not be able to achieve the rest of its mission. Yeah, there was some talk about how this was there was some there was a relationship between JAXA, the Japanese Space Agency, and a toy manufacturer, one that's famous in Japan. So like the Transformer toys, it was the certain vehicles or sub-vehicles, let's say, of this JAXA mission were designed to change shape to move across the moon's surface. All right, I'm going to call it there. Thank you very much. I hope you have a wonderful weekend. And chat, we will talk soon. Bye bye.